Starship Flight 7 may not have gone as planned, but SpaceX shows no signs of slowing down. Preparations for Flight 8 are already in progress, and significant advancements are being made on the second launch pad at Starbase. Let's delve into the details of these exciting developments. To start, the FAA has formally initiated an investigation into the anomaly that led to the destruction of Ship 33 during Starship Flight 7. Following the explosion, the FAA activated a debris response area to ensure the safe redirection or grounding of aircraft, preventing potential hazards caused by falling debris. This action indicates that fragments from the vehicle may have extended beyond the designated aircraft hazard zones, raising concerns about risks to air traffic and populated areas. Also, people residing in the Turks and Caicos Islands, over which the ship exploded and debris was observed falling from the sky, reported fragments landing in their backyards. Meanwhile, SpaceX assured the public that Starship remained within its designated launch corridor, and any debris would have fallen within the planned hazard area. However, the temporary redirection of flights and reports of debris reaching populated areas suggest that some fragments may have strayed beyond the planned containment area. If the FAA concludes that the debris indeed fell outside the hazard zones or finds significant safety lapses, it could enforce stricter regulations, requiring SpaceX to make significant design or procedural changes, potentially delaying Flight 8. Preliminary investigations revealed that the Flight 7 anomaly was caused by a propellant leak in the cavity above the ship's engine firewall. The resulting pressure buildup led to engine failures and the loss of thrust, causing Ship 33 to re-enter Earth's atmosphere in an uncontrolled descent, where it ultimately exploded. To address these issues, SpaceX has proposed measures such as improving leak detection protocols, adding fire suppression systems in critical areas, and enhancing venting capacity to prevent similar incidents. While these steps aim to improve safety, ongoing investigations by the FAA and SpaceX are necessary to identify all contributing factors and finalize any additional corrective actions. Although Elon Musk has expressed confidence that SpaceX will be ready for Flight 8 as early as next month, the liftoff date ultimately depends on the completion of the FAA's investigation into the Flight 7 anomaly. Currently, the Starship fleet remains grounded, and only after the investigation is concluded, and SpaceX implements the recommended safety measures, including adjustments to the ship's design, will the company receive the necessary approvals from the FAA to proceed with the next launch. More details regarding these matters are expected in the coming weeks. In the meantime, following its successful mid-air recovery, Booster 14 was carefully lowered onto the orbital launch mount for initial safety checks. Afterwards, it was removed and transported back to the production site for detailed inspections and analysis. Although there is no official confirmation yet, reports suggest that SpaceX is considering reusing Booster 14 in an upcoming flight test. This decision will hinge on the results of its ongoing inspections, and the determination of whether the booster meets all safety and performance criteria for another launch. After the Flight 7 anomaly, activities at Starbase quickly ramped up, demonstrating SpaceX's commitment to progress despite setbacks. Preparations for Flight 8 are in full swing, with Starship 34, the ship designated for the next mission, completing its cryogenic proof testing this past week. The ship underwent 2 consecutive tests on January 17th and 18th, during which both its methane and oxygen tanks were filled to capacity with liquid nitrogen. Simultaneously, hydraulic rams installed on the test stand applied force to the aft section of the ship, simulating the stresses it would endure during flight. These tests not only confirmed the reliability of the plumbing but also provided valuable data on the ship's structural integrity under simulated flight conditions. Once the cryogenic proof testing was completed, Ship 34 was returned to the production site and moved into Megabay 2 for further processing, including engine installation. The ship will soon be ready for its static fire test. Meanwhile, Ship 34's partner, Booster 15, is inside Megabay, undergoing engine installation in preparation for its static fire test. This test will take place once the launch pad is ready, following the ongoing post-Flight 7 checks, inspections, and repairs. Given the current pace of operations, Booster 15's static fire test is expected within the next 2 weeks. The construction of the second launch pad at Starbase has made significant progress following Flight 7. Just 1 day after the flight, the carriage that moves the chopstick arms up and down the launch tower was rolled to the site. It was then placed on the assembly jig to prepare it for integration with the chopstick arms. Early Monday morning, both arms of the Pad B launch tower were rolled out to the site and positioned near the pad, where they are now being prepared for integration with the carriage. Notably, the arms for Pad B are shorter than those of Pad A, with a reduction being approximately 30%. This design change appears to be motivated by several factors, including lessons learned from earlier tests and operational considerations. One key issue encountered during the initial tests at Pad A was excessive vibration, which posed a risk to the precision needed for catching the booster and upper stage of the Starship. By shortening the arms, SpaceX aims to mitigate these vibrations, reduce the overall mass of the structure, and improve the dynamics involved in the catch maneuver. Shorter arms also allow for faster response times and more efficient control algorithms for the catch. Soon, the arms will be integrated into the carriage using the assembly jig, after which the entire mechanism will be lifted and installed on the tower. A few days ago, roller skates were installed on the tower to facilitate the movement of the carriage chopstick assembly. These skates consist of specialized wheels mounted on tracks, allowing the carriage to move smoothly along the tower. Once the carriage is connected to the skates, the drawwork mechanism, already in place, will be used to control the vertical movement of the entire system, enabling it to be raised or lowered along the tower with precision. Meanwhile, work on the Pad B flame trench system is progressing well. The excavation for the trench is progressing smoothly, and teams are now focused on installing the pipes and conduits that will supply both propellants and electrical power to the pad. The existing tank farm is being expanded to meet Pad B requirements. After the integration of new propellant storage tanks several weeks ago, teams are now working to install new pumps and heat exchangers to ensure the efficient delivery of propellants to the pad. At the Sanchez site, construction of the Pad B launch mount is moving forward. Welding continues to secure the individual components of the mount, and plumbing work is ongoing within the structure. However, some major installations are still pending, including the booster hold-down clamps and the 20 outer quick disconnect mechanisms that supply gases to spin-start the outer 20 engines of the booster. Once the flame trench is completed, the launch mount will be positioned on the trench and connected to the surrounding infrastructure. Given the current pace of work, Pad B is expected to be operational by mid-2025. Turning our attention to the production site, the assembly of Starship 35 is progressing inside Megabay 2. The common dome of the vehicle has recently been integrated with the previously stacked sections. The ship's primary structure will be completed once 2 more ring sections are added. Starship 35 is slated for Flight 9 and will be paired with Booster 16. The stacking of Booster 16 has already been completed, and preparations are underway for cryo-proof testing. Meanwhile, the assembly of Booster 17 has begun inside the Megabay. This booster is likely to be used for Flight 10. Numerous other ship and booster sections are also being constructed within the Star Factory and will be ready for stacking in the upcoming weeks and months. Construction activities for the Starship launch pad at Kennedy Space Center's Pad 39A have resumed after a 2-year hiatus. The construction of the flame trench began last week, with piling work now in progress. The new pad will closely mirror Pad B under construction at Starbase, incorporating a flame trench and an updated orbital launch mount. Assembly of the launch mount components is already underway at SpaceX's Roberts Road facility within the Kennedy Space Center. If the schedule proceeds without delays, the Kennedy Space Center Starship launch pad is expected to be operational by next year. Elon Musk recently shared updates on SpaceX's ambitious plans to significantly increase the size of the Starship launch vehicle. The company aims to scale up both the Starship and its booster to meet the growing demands of future missions. Currently, the full Starship stack stands at 123 meters tall, but Musk announced plans to extend it by an additional 10 meters. Along with this vertical expansion, the diameter of the vehicle will also increase from the current 9 meters, though the exact new diameter has not yet been specified. Musk has previously stated that the long-term goal is to reach a full stack height between 140 and 150 meters. This ambitious expansion is made possible in part by the ongoing advancements in the Raptor engine technology. Over the years, SpaceX has significantly improved the performance of its Raptor engines. Each new iteration has brought enhancements in both thrust and efficiency. The latest Raptor 3 engine, for example, delivers a 22% increase in thrust compared to Raptor 2, and a 51% increase over Raptor 1. Furthermore, SpaceX plans to further enhance the Raptor 3 design to achieve an impressive 300-ton force of thrust. These improvements in engine performance are crucial because they enable SpaceX to increase the size of the Starship without compromising its overall performance. With more powerful engines, SpaceX can afford to boost the vehicle's size, increasing its propellant capacity and potential payload space. Additionally, the expanded diameter could accommodate more engines, providing a further increase in thrust and payload capacity. These upgrades are essential for SpaceX's ambitious plans to support interplanetary travel. A larger Starship can carry more supplies, equipment, and passengers, thus facilitating long-duration missions to destinations like the Moon, Mars, and beyond. Now, let's discuss the latest updates from the world of science and technology. The Indian Space Research Organization marked a significant achievement in space technology with its SpaDeX mission. Launched on December 30th atop a PSLV rocket, SpaDeX, or the Space Docking Experiment, aimed to demonstrate critical technologies for orbital rendezvous and docking. The launch successfully deployed two small satellites, named Spacecraft A and Spacecraft B, into a low Earth orbit at an altitude of approximately 467 kilometers. Each satellite weighs around 220 kilograms, with Spacecraft A designated as the chaser and Spacecraft B as the target for the docking experiment. After separation from the launch vehicle, the satellites began orbiting Earth independently, setting the stage for their rendezvous. Initially spaced about 20 kilometers apart, a series of controlled orbital maneuvers progressively reduced the separation, with the chaser pausing at predetermined hold points to perform system checks and ensure the safety and accuracy of the approach. The docking, originally planned for January 7th, was initially delayed to accommodate additional system validations. Subsequently, on January 8th, a maneuver to reduce the separation to 225 meters encountered unexpected trajectory drift, increasing the distance and altering the chaser's attitude. Over the following days, ISRO engineers worked diligently to correct the drift and restore the desired separation. Once the situation was stabilized, the chaser resumed its approach toward the target under careful monitoring at every stage. At a distance of 3 meters, the chaser conducted a final safety check, followed by a trial docking procedure to validate its readiness. On January 16th, after confirming all systems were fully operational, the chaser executed the final docking sequence, achieving a secure connection with the target. This made India the fourth nation to accomplish an orbital docking, highlighting the precision and reliability of ISRO's navigation and control systems. Post-docking, the satellites operated as a single unit, enabling experiments critical to in-space infrastructure. One such experiment demonstrated the transfer of electrical power between the spacecraft, a critical capability for in-space infrastructure such as space stations or servicing modules. ISRO plans to undock the spacecraft in the coming days and perform multiple docking maneuvers, with the inter-satellite distance reaching up to 100 meters. These tests will focus on the docking procedure and final approach to further assess the system's robustness and reliability. These redocking trials are vital for missions requiring multiple dockings, such as satellite servicing or space station maintenance. Once all the tests are complete, the satellites will undock for the final time and continue independent operations in orbit for up to 2 years. Each spacecraft is equipped with advanced scientific payloads to support various standalone mission objectives. These include capturing high-resolution imagery for natural resource monitoring, conducting vegetation studies, and measuring the radiation environment in orbit. The SpaDeX mission represents a monumental step forward in India's space capabilities, particularly in mastering docking technology. This achievement lays the groundwork for ambitious future missions, such as Chandrayaan-4, a lunar sample return mission, and the Bharatiya Antariksha Station, India's planned space station set to be operational by 2035. Thank you for tuning in for the latest science news and Starship updates. If you enjoyed this video, please hit the like button, leave a comment, and share it with your friends. Also, don't forget to subscribe to the channel and turn on notifications so you never miss an episode.